Man, it's too bright. It's so far. It's so far. Zero. There we go. There we go. The light switch is on my side, and it's really far away, and we can't change the light bulbs. So we were just like, I should make something. Uh, so I made this. It's a program. Well, this is a putty launcher, which launches putty connected to a to my COM16 port, which is basically just this Arduino with some tape around it and a USB cord extender running all the way to this hub uh, because I didn't want to plug it into there. Excuse me. So when you start this putty window, it restarts the Arduino on COM port 16, and it says, I am your light switch, press 1 to turn on, and press 0 to turn off. It's, whatever it's called, SG90, I think? Yeah, it's been a while. This is part of a bicycle spoke, one of my broken spokes, so it's just hot glued with some gold glitter glue. The same gold glitter glue that I used on my my vertical laptop stand because I use it as a server for all of my files when I'm home, and then when I go to class, I just unplug the Ethernet, you know. But yeah, some foam core board, this little thingy. So this slides on and off the switch, and then this part itself works as a hinge, while this goes this way and this way. So right now you can actually freely move this. And I'll explain the code, like why that is. And if you don't want to use it, say you just want it directly, you can still do that. Let me turn off the flash. So right now it's in the on state. Then I'm gonna turn the lights off, and probably a good idea to turn on the flash. So I'm gonna press 0 on the keyboard. I'm gonna press 1 on the keyboard. So look closely at the servo. Press 0 and press 1. Press 1 again. See? It's already up, so it won't go down. So let's look at that code. This is just a putty window with a custom launcher, so all it is, you know, that weed symbol, and it just goes to my 3C program files, x86 putty.exe, and then does just a simple load, and then the profile, which I have set up as light. And if we go into my putty, you can see it right here, which is just the, well, you know, COM port 16 right here. It's a serial with a 9600 baud rate, and with 8 data bits, 1 stop bit, no parity, and no flow control. This is the same setup that I have for everything else that I connect to with putty, so I don't have to launch the Arduino thing. So here's the actual code. Of course we're running a servo. It's really freaking simple. I don't even know what these are. Oh yeah, this is just stuff that I used to have in there. It's for testing. So we have the servo library right here, and then we just say we create the object, the servo object. So servo is the name that I've named the one servo that's on there. I wanted to start the serial port at 9600, so it's a slow speed that won't, you know, it won't make extra work on the CPU, at least nothing too serious. And then these are just the start off print commands, because, you know, it's pretty ambiguous of what happens when you click this window, so I would like it that, oh right, it's running through here. So I would like it that it would actually print out some instructions on what to do. For some reason it's not doing it. I think it's because it's already opened. Yeah, it's because it's already opened. Here, so I can close that, open it again. And you can see that it did the print. So I am your light switch, press 1 to turn on, press 0 to turn off. So we have our loop right here, and it just goes, This is basically stolen from the serial thing, which is the example under communication, I believe, in serial event. I've always had an issue with strings. Oh, there's a weird issue with strings. It's because it has to fill up the buffer, and it has to find the new line character before it tells the event that, oh, I can push this string out. So really I just steal this part right here, which is just I change the while to an if statement, and then char equals in char, and then if in char equals this character, then I do stuff, which you can see right here. This is the way that I do all of my like Bluetooth serial and just regular serial. I just do the same thing. I just use single char because it's easier. I can do comma parsing, but that's a little bit like unneeded complication. So basically, if there's some serial data available, then it runs into here, and it goes char in char, so it makes in char whatever the character that it's read from the serial port. If the char is 1, so if the character is 1, which is right here, it connects the servo to pin 9, so it actually like tells in software that, oh, I should be pulsing pin 9 so that the servo can actually move to a location, and then it tells it servo.write at 150 degrees. So this is the on state, and then it does a little short delay to wait for the servo to get there, because sometimes they're fast, sometimes they're slow. We don't really know. And then we do a servo.write at 90 degrees. So basically, like, let's imagine that this is on and this is off. So it's right here. So let's say it's just at any position when you turn it on. And then we want it to turn on, so it goes to 150 degrees, waits for 250 milliseconds, and then it goes to 90. And then it detaches. So it waits a little bit so that it can go back to 90, and then it can detach the servo, so we can freely move the servo, and it doesn't waste any power. Doesn't fuck up my USB power because I'm running it straight off of the USB ports. Same thing with the 0. I figured that if I didn't do this write 90, so I didn't put it back into like if I didn't put the servo in a location that the switch was like happy with, or like, let's say there was too much, so once it's at 150 or 40 degrees, there's too much force exerted on the switch that you couldn't like just manually do it, because fuck, am I gonna turn on the computer just so I can turn on and off the light switch? No, that's dumb. So by having it at 90, it gives enough slack in the actual like foam core board that's turning the switch on and off. It gives it enough slack so you can do it manually. And regardless of the state that the switch is left in, you can just press any of the buttons and it will do whatever it's meant to do. If the light switch is already off and we want to turn it off again, it'll move, but it won't like affect the switch, or it won't break anything mechanically because it's already in a known position to start. So yeah, that's why I do this little bit. We could have just did what normal people do, or what normal programs are, and just like have the servo.attach in the setup and just never dealt with this. But like I said, I wanted to save some power. I wanted the servo to be able to move even if it's like not being used, so that way I can reduce the mechanical stress and less heat for the electronics to deal with. But that's basically it. So thanks for watching, and yeah. Well, I was gonna put a schematic, but now that you think of it, it's literally just the servo, and the data wire is, or the PWM wire on the servo is just on pin 9, a standard PWM pin. That's basically it. Thanks for watching. I'm done here.